Okay, hi everyone. I think it is already recording. Welcome to this webinar, which was already done 2 days ago, but I rushed through. So this one is a webinar which I'm taking my time with, still not talking too long, but giving you an insight into the fascinating world and topic of consciousness research. As you can see from a neuroscience scientific perspective. So we are not going to do mysterious stuff which is out of the scientific reach. Although consciousness is, of course, a very special topic in science and a very challenging one as well. This webinar is hosted by us, Conscious Basel. We were founded this January to bring together local scientists from Basel to study the most fascinating topic there exists in modern science, namely how the physical world, where the physical principles apply, is able to create a subjective conscious experience of the environment. So what is this step from the physical world to a conscious sensation of experiencing a world? Scientists from all natural scientific disciplines are welcomed, also related disciplines. So if you're studying psychology, psychiatry, medicine, you're perfectly welcome here as well. If you're not a scientist, even then, you are very welcome at our association. You can take part in our activities, discuss with us, bring in your own ideas, and experience this fascinating world. What we are doing is actually described on our homepage, www.consciousbasel.ch. You can go there. You can learn all about our association. You find the documents here for download. Also the application document. So in case you want to apply for membership, what would be absolutely great, you can do this here. You have some theory, which is still in progress concerning consciousness, and the projects which we are doing actually. So we have the knowledge management system, the substance database, and so on, and the courses like the seminars and webinars, where you can also register here with the registration links. And we are also offering tutoring in different disciplines as well. So if you're interested, go there and have a look. Okay, what are we going to address for this session? We will dive into the question, what is consciousness? There are some different ideas what it could be, and based on those ideas, theories have developed by scientists, by leading scientists. We will have a look at who they are. And some of those theories are very special. I mean, you have one approach which says everything lies in the complexity of a system and computation of information. And then you have theories which say it does not have to do anything with complexity and computation, but it is not a non-deterministic quantum approach, which is the fundamental base to give rise to conscious experiences. Actually, a theory developed by Penrose and Hameroff. We will have a look at this as well. And then we will see if we can draw any conclusions out of what we have learned. Maybe you have some your own ideas about what it could be. And then we will finalize with some tools and methods, which I cannot show you all of them because there are some YouTube videos and they will be blocked when I want to upload this video. So we have to make this webinar without those. And for the discussion, I mean, if you have questions, please reach out to us by email. and then we can discuss, or become a member, and then we can discuss on site, face to face as well on our events. Would be great. Okay, what is consciousness? I mean, you probably know what is meant if we say, oh, he is conscious, she lost just consciousness. We have some kind of idea, but it is, from a scientific perspective, not easy to get a definition. I mean, we have equations, physical equations describing black holes, electricity, quantum physics, but there is no such thing for consciousness, for the experience of our environment. Why is this? Some scientists think we should start now going to this direction, and they did, and they started as well. I always like to start with this image which shows actually our existence. We have a beginning and it goes somewhere, so there is an evolution of our existence. We have also here different models, of course, what the basis of our existence are. So you have the standard model, for instance, saying you had the Big Bang, expansion of the universe, the creation of particles, atoms, galaxies, stars, planets. Also organisms, living organisms, such as us humans. And it will go into the future, and at one point the stars will end glowing, and also the galaxies and everything will come to a big freeze, which will be the end of our universe. We have the Big Rip theory, which I think says that the dark energy is leading to an accelerated expansion of our universe, which is getting so fast that in the end it will tear apart all the existence into nothing again, which will be the end in this theory. You have the Big Bounce theories, I think there are several of them, which say you have the beginning, an expansion, but in the end the expansion gets reversed and will compact itself together to initiate the initial state, leading to another Big Bang. There is this confocal cyclic cosmology theory developed by Penrose, who says at the end, based on the laws of thermodynamics, all the mass will disappear through heat death, so getting absorbed into black holes and then transformed to radiation. And what we will be left over is only photons, and as they experience no time and no space, we would have the initial system leading to a next Big Bang. And then the Big Slurp theory, which is considering the Higgs field, which is now interacting with particles, giving them mass. It will come into a stable state, which will also be the end of our universe. I have some sources. If you are interested in reading more about it, you can go there and read those theories through those publications. But within this existence, we exist as well. You see here, we have a brain, and we think that the human brain is the most complex structure in the known universe. So you have the most complex structure of the whole universe in your head, so you can be proud. And this is already a point which scientists say is important to have to be able to consciously experience the environment, complexity. And the more complex a system is, the more information it can take out of the environment and integrate it, so link it together, compute it, so that this computation in a very complex, maybe also orchestrated way, is the principle which allows the system to have an idea about its environment and to be influenced by its past and to be able to determine its own future. Based on this idea, different theories have been developed. So there is this IIT, the Integrated Information Theory, which exactly explains this integrated information approach. You have the higher order theory, which says a representation which you have from the environment is actually not conscious, but you need to have a higher order representation of the representation, so a meta representation of the representation. And this meta representation is the conscious percept of the lower order representation, the higher order theory. You have global workspace theories, different ones. There is the global neuronal workspace theory. And they say as soon as the information which is coming into the brain is made globally available, the global availability of information within the brain is the principle giving rise to conscious experience, and that you have in the frontal cortex the role of orchestrating this broadcast across the brain to give rise to conscious experience. Then you have the predictive processing. Predictive means that if you have an incoming signal into the brain, this signal gets checked, and based on what memories you already have, the brain predicts an expectation of what that signal should be. And if this signal, or if the expectation is not according to the real incoming signal, there will be a correction of this prediction error. So it's a back and forth signaling loop of expecting the signal to be something, leading to a conscious experience in the end. But when you hear this, I mean, those are all approaches trying to physically describe how information is being processed. But the fundamental mechanism, how this signaling and complexity is giving rise to a subjective feeling of being something, is still not explained through those theories, right? So there is still a hard challenge of understanding this, which neuroscientists call the hard problem. So all this connectivity, all this signaling is considered the easy problem because we can measure it, we can study it, we can have a look at it and see what happens if we change something through cognitive experiments. But then the hard problem of how this gives rise to the subjective experience is still not solved. Therefore, you have theories like the orchestrated objective reduction theory developed by Francis Crick. No, this is not true. By Sir Roger Penrose, who got the Nobel Prize, by the way, for describing singularities within black holes. He also worked on consciousness studies. He worked together with Hameroff, and they developed this orchestrated objective reduction theory, which says the whole principle of conscious perception does not lie within the computational power of a system. It has to do something with a non-deterministic approach. He bases his ideas on the Gödel's theorem, which is a mathematical principle, which I can show you afterwards as well. Based on this, in quantum physics, you have quantum states. They can decay. We will have a look at it, how this can happen. And the decay, or what causes this quantum state to decay, is physically not understood. And he thinks that this is non-deterministic, and based on Gödel's theorem, consciousness needs to be taken there to make this collapse happen. So everywhere where you have quantum state collapses, you have consciousness which is leading to that collapse, to that measurement of the wave function. So whenever you have single particles in a quantum state decaying, there is a so-called proto-consciousness which can combine together in complex systems such as the brain to a whole human brain, human consciousness of the environment. A little bit abstract. And of course, we do not know what of those theories are true or not, but scientists are trying very hard to exclude some of those theories, to prove other theories, and to finally reveal what might be the truth in the end. In general, from a philosophical point of view, and science is philosophy, so at the university, at least in Basel, you study at the philosophical natural science department, so philosophy is the base of science, right? Is first of all dualism, and on the other hand you have monism. Dualism means, dual has the word two in it, that you believe in two different worlds. You believe in the physical world, which is described by our physical equations, physics, and on the other hand you have the so-called non-physical world, where the soul, our thoughts, our feelings and consciousness is situated. On the other hand, you have monism, meaning monists believe only in one single world instead of two different ones. And I will show you now on the next slide what we mean by this. So the most famous dualist, I think, is René Descartes, cognito ergo sum, je pense donc je suis. I think, therefore I am, in English. So he thought about existence, and he lived in the 16th and 17th century, I think. And he was a typical dualist, and his point of view is considered the dualistic approach, who thinks that there is a physical and non-physical world, but the pineal gland in the brain, which is a structure involved in the sleep-awake cycle, and he thought that because this pineal gland is changing actually the conscious states of a person, that this pineal gland is the gate between the physical world and the non-physical world. And then for monists, you have three different types of monism. I think a lot of modern scientists are materialistic monists. I mean, there are also special types of dualists. I mean, you can take reality as granted, as one world, but then think that reality is like a coin which has two sides of the same thing. So it's a mix between monism and dualism, which exists as well. But the classical idea, let's go to the monists, is that you have idealism, which says there is only a non-physical world, and the physical world which we experience is just a projection of our thoughts. Then you have the materialism, which is the reverse. They say, no, the only world which we have is the physical world, and everything, also thoughts, experiences, is an effect of the physical mechanisms which are going on in our universe. And then you have the neutralists who say it's neither of those, but it's something else, which you first need to understand what it could be, creating our conscious experience. And as I said before, based on those two main philosophical standpoints of views which you can have, the theories are developed, and you can say what theory is belonging to what philosophy. So the integrated information theory is most probably a monistic approach. As I said, introduced by Crick here. Crick and Koch, they work together. Francis Crick, who published on the DNA structure. He also thought about consciousness and tried to find ways how we can study this. So this is a monistic approach. And what panpsychism means, we will come to that in a bit. In panpsychism, you actually annotate a conscious state based on the computational power of a system. So also a stone does also maybe process information to some extent. So he has a potential of integrating information. And therefore, this system has a conscious state which is very low, but still has one. And this state is measured by this one value phi. What the integrated information theory people like Christoph Koch and Francis Crick do to find this principle of integration of information is looking for the neuronal correlates of consciousness, the NCC, which is the smallest set of neurons or neuronal activity giving rise to a conscious percept. So it's localized. They say consciousness is localized. So if you cut your spinal cord, you are still conscious. If you remove the cerebellum, which contains 80% roughly of all the neurons in your brain, you are still conscious. Depending on seizures in your brain or lesions, if you have a tumor, seizures and so on, you might be still conscious, but in other parts, when they are damaged, then you are maybe not conscious anymore. And by this, they try to see what parts of the brain contribute to conscious experience, and then go inside and see how the neural circuits are looking, how cell communication is happening, and try to find a set of neurons, those neural correlates of consciousness, for instance, which give rise to see in color. And if you would turn off those neural correlates of consciousness which are responsible to see in colors, you would only see black and white again. Black and white. And then you could switch them on again, and then you would see in colors again. Switch off, black and white, switch on, colors again. So this is actually the aim. As we said before, Sir Roger Penrose would say this is still not enough to describe the physical, the most fundamental understanding, this quantum gap of how the physical world can introduce a subjective feeling, and would state that the organized quantum effects, which are coherent, decay, and the decay is important for this giving this rise. Then the global workspace theory, where information is globally made available, is also a materialistic monistic approach, orchestration in the brain. Then you have this orchestrated objective reduction, as I said, made by Penrose and Hameroff. Objective reduction is this decay of the quantum states. Then you have this higher order theory, which we saw before. You can actually describe this meta-representation of a representation as thinking about a thought. And the thinking about the thought is, by definition, the conscious experience which you have. And then you have this predictive processing, where you have this error minimizations of expectations in your brain. And Anil Seth and Hermann von Helmholtz are people and scientists who has this standpoint in science. We will have a look at nice thought experiments which they did on the next slide, because the way you think about consciousness is doing scientifically thought experiments which help you to understand the problem and to find approaches of how you could study this very complex topic. And then you have dualists. So beside Descartes you have Thomas Nagel, Frank Jackson, and David Chalmers is still living. He's, I think, a mathematician or physicist who is exactly a modern dualist, who is, I think, thinking about the world to be one, but having two sides of the same aspect. He's such a dualist. Okay. Coming now to this slide. Now we will have a look at those thoughts which those scientists did. They're very helpful thought experiments which we are going through now. And you see some are coming from dualists, some are coming from scientists supporting the predictive processing theory, and then we will have a look at the integrated information scientists as well. So Thomas Nagel, he asked the question, what is it like to be a bat? This is actually a question which we can ask ourselves if animals in general have conscious experiences. What animals? Is it only primates? Is it all the animals? Is it a squat, for instance, or a bee? Or is it even plants? And what requirements are there sufficient to give a conscious experience, which is called the quale? So if you see a color blue, the blueness of that color which you experience is called the quale, the qualia. And the question here, he asked if a bat also have this qualia, and what it would be like to be. So, I mean, if you fly around as a bat, you don't have an inner language, you have different sensory systems. You feel different, right? So does it feel to be a bat? So this is an open question. Then you have this Frank Jackson, who did this Mary thought experiment. He thought about Mary, who grew up in a completely black and white room. She has never experienced any color, but she knows all the physics there is. She knows also the physics we still do not know. Let's consider this hypothetically. And the question is she able to know what the color green will look like? Monists say, yeah, sure, because she knows all the physics. She knows how the electromagnetic waves are being processed and giving rise to conscious experience, and how this experience will look like. And dualists say no chance. I mean, if she has never seen it, there is an information missing which she needs to be able to know what the color green will look like. Then you have this David Sharma, this modern dualist, who says we know that we are conscious because we experience the world through our consciousness, but there is no way that we can be sure that someone else is also conscious. So they might behave as they would have a conscious experience. They answer questions in a very conscious way. They behave like us, but there is no way to prove that it is like this. So we have to assume that everyone else beside us is a zombie. So this is this zombie theory. Then you have Hermann von Helmholtz. He says it's all about expectations, so the principle of predictive processing. The principle can be visualized by a very famous example, which is called the Freudscher Versprecher, Freudian misspeller. You read a book out loud in front of the class, and you read a word which is not standing there. And you read it because you were expecting it to be there, but it was not. So your sensations expect the incoming signal to be like something, and based on this, it will create your conscious experience of the environment. Simple explanation of the expectation process in cognitive neuroscience. Then you have Anil Seth from the University of Sussex. He says, when we take serious the physical principles and the materialistic monistic approach, then we are nothing else but robots. So if everything is based on physical principles, there is no such thing as consciousness. So consciousness does not exist. What consciousness is the processing of information in a highly complex system, allowing this system to hallucinate to itself a conscious experience to be able to live in that world. But it's in the end only a hallucination based on the computational power. So we are nothing else but zombies, but he does not call us zombies. He calls us, to differ a little bit from David Chalmers, he calls us Zimbos. So we are all Zimbos. This is the Anil Seth theory, or point of view. Then we have Christoph Koch and Francis Crick. The neural correlates of consciousness people, and it is visualized here again. So you have a dog. The signals come into your brain and gets integrated, and by the neural correlates of consciousness, you would get a conscious perception of the dog. I mean, you need to integrate information with memory, with face recognition centers, with experiences you have made, with feelings. Maybe you're afraid of the dog, then the amygdala might shoot in as well. So a lot of things which need to be combined to in the end create one single conscious experience of that dog. Okay, let's go to the next slide. Theories of conscious perception. So let's summarize the theories again so that you have a nice overview over the theories. So in principle, what you can study in consciousness is the states of consciousness and the contents of consciousness. So the state of consciousness, and by the way, this is a visualization which I made by myself based on the Seth paper, Theories of Consciousness. So you can have a look at this paper. It's interesting summary. So you can study states of consciousness, which is wakefulness. Another state could be sleepness. So if you fell asleep, you might be still conscious, because you might be conscious about your dreams which you have, right? You could be treated with anesthetics and be in a different state as well. So those are states which you have. And in each state you can have content of consciousness, which is the experience itself. So color is a content, shape, selfhood, or the feeling of being something, emotions, spatial location, and so on, thoughts. And this can be studied and taken as tools within the theories which we have discussed to find out what theory might be correct and what not, which one might be not correct. And here is an example. It is called the binocular rivalry, where you have a participant in an experiment, and this participant looks through a binocular. With the left eye, this person sees vertical stripes, and with the right eye, this person sees horizontal stripes. At the same time, this person looks through the binocular. So the input signal, the visual input signals are the same. But you as a person are not able to see and consciously perceive both different states at the same time. So either in your head you're able to perceive the horizontal stripes or the vertical stripes, and you also can switch between the left and the right perception in your head. And this, for instance, can be used because the input signals is the same, but the perception is different. So you go into the brain and see what changes in concern of neural activity, for instance, and you can define neural communication and circuits where you can say those neural correlates for this conscious experience is located there and there, and those neurons are necessary for perceiving either this state or the other state. And this you can do in the different main categories of theories which we have discussed. So the integrated information theory, they think based on such experiments that integration of information is happening in the so-called posterior hot zone. But the ones who contradict this theory say, yeah, but if we are doing highly cognitive tasks, then it is mostly the frontal and prefrontal cortex which show the most activity. So why do you exclude the prefrontal or the frontal cortex? The integrated information theorists say it is this posterior hot zone, and the frontal lobe activity is active, but not a direct correlate of conscious experience. For the higher order theory, you have this representation of the representation, and the higher order representation, so the thought about the thought, would indeed be the prefrontal cortex. The global workspace theory, where information is made broadly available and which is orchestrated, is also saying that it is most likely including the prefrontal cortex as well. So you have contradicting statements. Integrated information theory, it's the back, the posterior hot zone. Global workspace theory says it is prefrontal cortex, frontal lobe. And they did indeed just now an experiment, or they analyzed data at least, where they tried to show which of those theory is correct. This was this Professor Meloni, I think, from the Max Planck Institute in Germany. And what they found out, by the way, they belong all to this Association for the Scientific Study of Consciousness, which is a global association where the leading experts in this field are part, and Meloni is, I think, also a member there, and they did this study and they found out that both of those theory are true to some extent, and that the fundamental principles are still not clear. So it's still not clear. But those are those two theories. And then you have this predictive processing, which is going on as well. Yeah, that's it, I think, for this slide. Yeah. What we have in the integrated information theory is an idea of how we could derive axioms for consciousness, which would help, again, to understand consciousness. So first, axiom is you need to have existence. You know that you are conscious, so consciousness exists. You have a composition of phenomena. So conscious experiences have distinctions, and they have also structure. Consciousness has specific information. A system state makes a difference by ruling out many other possible states. Consciousness is an integrated unity. So if you perceive a dog, for instance, you are not only perceiving its face and separately its color and separately its smell and separately something else. It's one perception of that dog. And your experience is also singular. So you do not have several different consciousnesses about the world. You have one consciousness. You define yourself as one person. This is called the singularity, the unity, and the existence and the composition and the specific information axioms of consciousness. What is interesting is that you can also play around with this to study consciousness and the mechanisms. If you have, for instance, split brain patients where you cut through the corpus callosum. Corpus callosum cutting leads to the fact that the right hemisphere is not able to communicate with the left hemisphere anymore, at least to a significant extent. Your language understanding and producing is on the left hemisphere. When you now give such patients a written out instruction which is projected onto the right hemisphere, and the person reads knock 5 times onto the table, then he receives this instruction with the right hemisphere and knocks 5 times onto the table. When he gets asked why he just knocked onto the table 5 times, which is perceived by the left hemisphere, the left hemisphere, who is understanding the question why he did this, is not able to communicate with the right hemisphere. So the left hemisphere does not know. And patients make up some random stories. Yeah, I was bored, or yeah, something else. So is this already a state where you have two different consciousnesses in one head or not? And how much connectivity is needed to combine, to fuse together the conscious experience to one unity? Yeah, very interesting. You can think about it yourself. Okay, summary again. The higher order theory says you have a lower order representation, which gets meta-represented to a conscious state by a meta-representation. So you think about a thought, for instance. The global workspace theory, which makes information globally available, so by orchestration of the prefrontal frontal cortex, maybe. Then the integrated information theory, where you have the posterior hot zone, and then the predictive perception theory here. Yeah. I mean, what we can say here, this phi, we said before, the integrated information theorists annotate a complexity index, I would call it, maybe of a system being able to integrate information, which is phi. And this phi, I mean, when you have a diamond and light is shining into this diamond, this information of that photon is integrated somehow, maybe, to a very, very low extent. So this diamond has a phi value, but very, very low. Is it already enough for this diamond to feel like being something or not? The panpsychists say, I'm not sure what they say, maybe it's a too low phi, maybe there's a threshold phi which you need to reach to be able to feel like being something. But what Koch says, Christoph Koch, is when you take the simplest single cell which we know, it is already so complex so that it cannot be simulated with all the human-made computational power there is. It is so complex if you consider all the biochemistry, you know, that it is already so complex that it might integrate information to this extent that it is able to feel like being something. And that the more you structure it together to a whole organism, like a human, this consciousness builds up together to a full human consciousness somehow. Yeah. This is, I think, all I wanted to say to this slide. Yeah, so based on those four main categories of theories, you have several a lower order theory belonging to one of those main theories, but you also have this orchestrated objective reduction theory, for instance, which takes a totally different approach, which we are going to have a look at a little bit so that you get an idea what it means, and then you can think what theory makes more sense for you. Of course, in the end, it does not matter what you think, it doesn't matter what I think, it doesn't matter what anyone thinks. In science, we want to find out the facts, right? So we need to find out what the reality is, and I mean, this is not very easy to do. In the end, we want to find out, is the Mary thought experiment an experiment where Mary will know how the color green will look like, or does she need this special extra information? And if yes, how does this look like? Okay, orchestrated objective reduction, developed by Sir Roger Penrose. You see, he has the Nobel laureate medal around his neck. He got the Nobel Prize. And Stuart Hameroff. The Consciousness in the Universe, a review of the orchestrated objective reduction. You can read it by yourself. It is interesting, but be careful. It is not the newest publication. So Penrose has also already some new ideas about this theory, which are not up to date in this paper, but we will go through. The base and the fundament of Penrose's thoughts is the mathematical Gödel incompleteness theorems, which basically state that you can have in the universe statements which cannot be proven. And which are still true. And the thing that we know that those non-provable statements are true is only the conscious state. Only by consciousness we know that a non-provable system is true. And this is in the case in the non-deterministic quantum physics, where a wave function decays. And he looked for structures in the brain where this can happen, and they found out that it might be the microtubules, where the quantum states build up coherently, and then at a certain amount, where they reach a threshold of gravitational self-energy, they decay, and the moment of decay is the moment of conscious perception based on a non-deterministic approach necessary for knowing that statements can be true, although they are not provable. So Gödel's theorem, let's make it not too long. I mean, you have axioms by which mathematical statements are built up, but they are set, they are human-made, right? So we say 1 and 1 is 2, it might be an axiom, and we say this is true, but is it really reflecting the reality? We cannot know if they are really true. It's a human-made up axiom which we take as granted, which we take to do math, but we are not sure if it's true, right? So for instance, for the Euclid's axioms, you have a triangle with and you can make the axiom on this the axiom that the sum of this of all angles in this triangle is always 180 degrees, and it is true for all the triangles you draw on a paper and so on. But then you draw a triangle onto a sphere, and suddenly you recognize, oops, the amount of angles in a triangle is greater than 180 degrees. So the axiom here is right, and it is right throughout your whole experience of the whole universe, until you go to special conditions where you realize it is not holding anymore. I mean, the same holds for the Peano axioms, right? You have a natural number, you add 0 to it, you still have the same natural number. Yes, it perfectly makes sense. It is logic for us, but is it really reflecting the reality? We do not know. The same, you have a natural number, you multiply it with 0, you come up with 0. Yeah, makes sense for us, but we cannot be sure if it is really reflecting the reality. But what you can do is, you can make those definitions and say, let's assume they are correct. And based on this assumption, you can make mathematical statements. What is truth? Big philosophical questions. Is math nature given, or is it made up by humans? With this, it's for me, in my opinion, it's clearly made up by humans. It is consistent in our world, which we perceive, and in our conscious experience of our surrounding. But in the end, I mean, conscious perception is a way of the brain to deal with its environment. We learn how to interpret things, and we make the world up and puzzle it together so that we can live in. But for instance, if you take active substances, drugs such as LSD, it's very well documented by Albert Hoffmann, who drove on his bicycle the way home across the marketplace in Basel. It's very well documented. He says, what happens is all your experiences fall apart into their individual perceptions, and it takes some time to put them together to a puzzle. And consider 80% roughly, I think, of all the information which is coming into your brain is filtered out by your brain. Because if all the information would come into our brain, it would be too much. It would not be possible to process all this information. So we don't have access to 80% of what our reality looks like around us. So it's a made-up world, hallucination, as Anil Seth would call it, to be able for us to live in this world, which is most likely not what the real world looks like. And I mean, a snake perceives the world quite differently. Even you might perceive the world completely differently than me, because if we both see the color blue, what I see as color blue, you might see as red. You might see red, but you call it blue because we both learned that this is the color blue, but we might perceive it in a different way. So your conscious experience of the world is a totally, maybe not totally, but to some extent different one than mine, right? So, okay, let's go to the next slide. Peano's Gödel theorem. So you have the axioms which you have defined to be true in a consistent formal system P, meaning there are no contradictory statements, and you use those axioms to make operations based on the axioms, which are the rules, and you come up with mathematical statements. And what Gödel did is he annotated to each axiom, to each operation, and to each statement Gödel numbers, put them into a matrix, and then somehow made the statement, the mathematical statement, there is no number that proves this sentence. So let's say this is the statement which we have derived by those operations. If the sentence could be proved, it would be false, since the system would prove a false statement, right? But if the system is consistent, which it is, because we defined it here, then the sentence is not provable. And this is true. But we cannot prove that it is true. So Penrose asked the question, what is it that we know that it is true? We only know that this statement is true because from a meta perspective, we know it is true. And this meta perspective is our conscious perception of the statement and its analysis, by which we know that it is true. Although we cannot prove it. And because we cannot prove what we know, the knowing itself cannot be proven. And hence, I mean, proving would mean be computed by those axioms and operations. So our understanding of this sentence to be true cannot be computed. So it must be a non-computable approach, a non-deterministic approach, which is quantum physics. So quantum physics gives us a possible solution for this problem. And what in quantum physics is it? It is the decay of the wave function. And you can read this in Roger Penrose's book, The Emperor's New Mind. Very abstract to understand, but I think he has some point here, right? So it makes sense, and it is very fascinating to think about this. And it might be, I mean, the integrated information theory, the global workspace theories, and so all the theories might be still true on a macroscopic level when it comes to computation, but the underlying fundamental physical principle which those theories still do not explain might be something like this. But as also Penrose says, I mean, what is a decay of the wave function? What is a measurement of a wave function? This is still open, and Penrose says we still have to learn this first because we can really understand conscious experience. What is this decay of the wave function? I just shortly rushed through. In the beginning I said I don't rush through, but now I do not want to make it too complicated with those quantum physics theories. So, I mean, what you have is the Schrödinger equation. You have potential energy which is influenced over time. So the wave function is influenced over time. There is time evolution and also in space. and you can set conditions. You can say it's a free particle, or you can put it into a box, and then you solve the differential equations. You come up with a solution, and the solution is the time-dependent wave function, giving you a probability distribution of position and momentum, which looks like this. So the particle is not here, or it's not here, or it's not here. It's everywhere, described through this wave function. The same for the momentum. This is exactly where Schrödinger comes up with his cat, Schrödinger's cat. It's not either dead or it's not either alive. It's everywhere. Although Schrödinger made up this cat analogy to fool with quantum physics, because he himself did not believe in this wave function. I think he was, I'm not sure, but I think he was also one guy who was convinced that quantum physics is deterministic and how stupid it is to think about the probability. So he made up the cat to show everyone how stupid this idea is, but it is how it is, right? So as soon as you measure, I mean, not measuring means there is no interaction of a measurement process going on, which allows this particle to be in that state. But as soon as you measure, and I will show you in the next slide what this could be, this probability decays to a concrete state. So you have a precise momentum, or you have a precise location. Yeah. But what really measurement is, and what makes the principal physical mechanisms of this decay are still unclear in physics. So if you find out, go to the committee, the Nobel laureate committee, and then you most probably get the Nobel Prize, I think. Okay, what is now this decay? So the wave function is probability distribution. Can be visualized by those waves. So water waves, they go through those two slits, they interfere, and you get the diffraction pattern at the screen, right? Meaning that you have this probability distribution. You have a certain probability that one photon, if it goes through this slit, goes here. You have a lower probability for the photon to go here. But as you shoot one photon, it goes here. You shoot another photon, it goes here. It goes maybe through this slit, maybe through this slit, maybe through both slits at the same time to give this this diffraction pattern. In the end, you come up with this diffraction pattern. If you now measure, put here a device to measure it, if it goes through here, this diffraction pattern disappears. So then you have this slit represented here, and the left one. And the interesting thing is that if you put a device here to measure if the photon goes through here, even if the photon goes through the slit which you do not measure, will still be discrete. So the photon who will go to the slit which is not measured knows that there is a measurement and will be concrete. So this photon knows that this slit is measured and considers itself as a measurement, and then the diffraction pattern disappears. So it's really strange, but yeah, very interesting. We can use it to understand our world, or to have even more questions as before, which is good in science, to have more questions as before, because you're one step further to maybe understand our world even better, which leads you to the complexity of our existence. Okay, so this theory is the theory or thinking about this non-deterministic behavior or feature of a wave function is challenged by some ideas. I mean, there is this many world interpretation which says that every possible state within the wave function is actually discrete but represented on a different world, and every state exists on a different world. Those worlds exist at the same time. It's a many worlds interpretation. So it is discrete but at a specific world. And there is the Broglie-Bohm theory, which says there is actually a hidden variable in this wave function which we do not know, but which would make this particle discrete from the beginning within the wave function. So there might be a probability distribution, but a variable which makes these states concrete. But this would be a problem for Penrose, because then the quantum physics world would be deterministic, right? But let's assume Penrose is right and quantum physics is non-deterministic. Then we need to ask the question, why does a wave function decay? And Girardi, Rimini, Weber, they put in a collapse term. So as soon as this collapse term leads to a collapse, the collapse happens. In the orchestrated objective reduction theory, which was developed by Penrose, he says that the more quantum states you have in a coherent state, there is a time where the based on the gravitational self-energy which reaches a threshold, the wave function collapses. So it's gravity. And then he said, not only he, but also Hameroff and the guys he worked with, that on the microtubules, they have such a structure that they allow coherent quantum states to build up and to increase until this gravitational self-energy reaches a threshold where all the quantum states, or it's one quantum state described to this coherence, in an orchestrated manner collapse. And this collapse is this conscious perception based on Gödel's theorem and everything which we said. They tried to prove it. I mean, they gave anesthetics to, I think, patients or maybe mice, I'm not really sure, but they tried to see how anesthetics influence the microtubules, and they saw interactions where anesthetics docked to microtubules and inhibited conscious perceptions. And then they tried to measure radiation. So if this coherent quantum state decays, some radiation, specific radiation, will be emitted, and people think that they have detected this specific radiation and tried to prove that this theory is true. But you also have a lot of other people, they did the calculations and showed that microtubules are too big to be the site for such quantum effects to be happening. And even Penrose himself nowadays says maybe it's not the neurons, it's not the microtubules, but it might be other structures, maybe within the layer 5 pyramidal neurons, which are responsible for that decay. Yeah. Conclusions. Okay, can you conclude something out of it? I mean, it's still an open question. Is conscious experience based on computational complexity, or is it a non-deterministic approach as suggested by Penrose? Maybe it's both, right? Maybe it's all big theories together, like integrated information, not objective reduction, global workspace theory, higher order theory, predictive processing theory, all combined somehow, but they are only being able to exist based on the fundamental principle of consciousness, which would be these quantum effects described by Penrose. Maybe it's something like this. Maybe it's something completely different, which we do not know. If you are a dualist, you still would say there is something extra which needs to come and so on. So very, very hard problem. But yeah, what can we do? Doing more experiments with new approaches, considering all the facts, all the results which we already have. Taking all arguments into account to be able to improve the approaches, because if you say, I do not want to have something with this theory, I only stick to my theory, I think this is the wrong approach. I mean, you need to be open for all the arguments to be able to understand what is really going on, right? So Higher order theory should not contradict the global workspace theory or the integrated information theory. They should say, okay, you have those thoughts and those principles. How does it fit with our view, and what might be the truth? And can we eliminate something? Yeah. And therefore, all the data needs to be shared with all the scientists, so everyone has all the knowledge to be able to conclude and go further. Yes, and how can you further study consciousness? You can use optical illusions where you get input signals into your brain and see how the input signals mismatch your perception. I mean, here the image is not moving, right? But you experience the image moving. You can use altered states of consciousness. I mean, here at the IOB in Basel, there was a group, they gave anesthetics to mice. They fell asleep and they had a look by live cell imaging, I think, system neuroscience, what changes in the head. And they found out that as soon as you give anesthetics, so the mouse falls asleep, goes from the awake to the asleep conscious state, that the cortical layer 5 pyramidal neurons, they were desynchronized, and during the fall asleep they got synchronized. So the loss of wakefulness, let's say conscious experience, correlates significantly with an orchestration in the cortex, layer 5 pyramidal neuron activity. And this is influenced, I mean, cortical synchronization is influenced by thalamic cortical loops. So how do they contribute to this effect? And is it only in a part of the cortex? Is it all over the cortex? How does it fit with integrated information to memories, maybe? I mean, can you be conscious if you don't remember? I mean, you first need to have an information processed already somehow in your brain to be able to consciously experience something, right? So without any memory, are you conscious? Big question. Then you can use effects like the change blindness effect. You see those two guys going through those two guys, and the black hat guy exchanges with the blue hat guy, and in a lot of cases the persons do not know or recognize this exchange. It's called change blindness. It has to do something with what information is important for you to keep up the conversation, most probably not what the person is or who this person is. Yeah, you can give active substances like psychoactive substances to see how they influence the cognitive functions and conscious perception by interacting chemically in the brain. Yeah, you can use the binocular rivalry as we already saw before. So you have the same, so left eye you have an input signal, right eye you have the input signal. The input signals do not change over time, but your perception within your head does. So you can go into the brain and look what causes the different perception to reveal the neural correlates of consciousness, or this B-stable perception where you have this it has a special name, this cube. But what happens is you can take either this or this as the front of the cube and change the state in your head. And also here, have a look at what happens. Yeah, that's actually the end of the introduction to consciousness research and the theory of consciousness. I think it's very complex, but so fascinating. And if we understand this, we are a way further to understand our whole universe, right? And the basic mechanisms of our existence as well. I mean, it's important also to understand if in silico systems at one point might be conscious. If it lies only in the complexity of a system, why does the internet not feel like being something? Maybe it does. But the problem of mimic the human brain is huge. As we said before, one single cell is already so complex that it cannot be simulated, right? So if you want to simulate the complexity of the brain, you would need to simulate the biochemical state of each single neuron. Besides the connectivity, you need to take astrocytes into consideration, which influence the biochemistry, for instance, at synapses. You need to think about everything, and this is so complex. I mean, at the moment, at least, not doable. But yeah, I mean, Christoph Koch says maybe the internet already feels like being something because it's so complex. And if, yeah, we do not know. Okay, my aim was to make you think about it, and yeah, if you want to discuss more and to get, I mean, we do journal clubs to bring theories together and new insights. We have events where we talk about this. We have our own projects to help understanding it. So if you are interested, reach out to us, join us, and yeah, let's make this existence more understandable maybe. Okay, cool. Thank you very much for watching. Great you were here, and see you later. Bye.